A 4-gram bullet is shot with a speed of 900 meters per second. The bullet gets lodged into a 2-kilogram stationary wood block. What is the speed of the bullet plus block after the collision? So we have two images drawn here. So initially we have this bullet that's flying at 900 meters per second into a stationary wood block, and then after the bullet gets lodged into the block, the two travel together. So first we have to ask ourselves, what type of collision is this? We have two options, elastic or inelastic. Because the bullet gets lodged into the block, we know that this is going to be an inelastic collision because they stick together and move as one after the fact. This is a conservation of momentum problem, or as I wrote it on here as COM, for an inelastic collision. So I go ahead and set up my equations. So on the left side of the equation, we got the mass of the bullet, mb, times the velocity of the bullet, vb, plus mass of the wood block, mw, times mass or velocity of the wood block. Now those two added together, of course, gives us our total momentum for the system initially. Now because the wood block initially is not moving, that means that the velocity here, VW, is 0. So that's nice because that just simply means that that term goes away. Now the right side of our equation, as you notice, we have mass of the block plus mass of the bullet added together. And the reason for that is because this is, again, an inelastic collision, meaning they stick together, so they move as one system. And ultimately we're trying to find that final velocity, v, on the right side of the equation to find the speed of the two after the collision. So now using our equation again, we know initially the only thing that's moving is the bullet. So 0.004 kilograms, remember this is a 4-gram bullet, so we have to convert it to kilograms, times 900 meters per second. And that is equal to mass of the bullet plus mass of the wood block, so 2 plus 0.004, and of course times the velocity because this is momentum. So again, just to kind of summarize here, notice that mv, we know that momentum is equal to mass times velocity, so the momentum of each individual component is then equal to the total momentum of the system in this inelastic collision. So the total momentum of the system is 3.6 kilogram meters per second, and again it is conserved, this whole idea of conservation of momentum. So the initial momentum, 3.6 kilogram meters per second, equals the final momentum. Knowing the total mass of the system after the collision, we can use that to solve for the velocity, and we see that together the block and bullet move at 1.79 meters per second. Now we see, compare that to the initial speed of the bullet, 900 meters per second. It is significantly slower, and that makes sense because the bullet has a lot smaller mass than the block. Now we're done with the problem, but let's ask ourselves, is energy conserved for an inelastic collision? When two things collide inelastically, like the bullet and the block, does energy get conserved? The only type of energy in this collision or in this problem at all would be kinetic energy. So if energy is conserved, we can say that 1/2 mass of the bullet times velocity of the bullet squared initially, plus 1/2 mass of the wood block plus velocity of the wood block squared initially. And as we know, the block initially is not moving, so like before, we can get rid of this term, is equal to 1/2 the total mass of the two combined times the velocity squared, the final velocity that we just solved for. So we go ahead and plug in our numbers. 1/2 mass of the bullet times the velocity of the bullet initially equals 1/2 the mass of the system times the final velocity of the system squared. So after we plug in our numbers, we see that the left side of the equation is 1620 joules, and the right side of the equation actually comes out to be only 3.21 joules. And clearly these two numbers are not equal to each other, so therefore energy is not conserved. And we can in fact see that the difference between the two, which is huge, that is how much energy is lost in the bullet after it collides with the block.